In this video, we're going to discuss the reactions of ketenes. Like nitriles, ketenes are acyl-like compounds. And if we think about the structure of ketenes, they actually contain a very electrophilic sp carbon, so they are reactive toward nucleophiles even at low temperatures. And when the nucleophiles add, they always add to the carbon. So to refresh our memory on what a ketene looks like, it's this. So CH2 double bond C, it has an alkene and a ketone. So it's called a ketone and an alkene is called a ketene. Certainly you can have R groups coming off of that carbon on the left-hand side there. The carbon in the middle is sp hybridized, and it's very electrophilic, and so it will add to a nucleophile, or a nucleophile will add to it, undergo an addition reaction like we've seen with other acyl compounds, and we displace that carbon-oxygen double bond. So the result looks like this. It's CH2 double bond C. Now there's a single bond to oxygen, so carbon sigma bond to oxygen. The oxygen has a negative charge, and now the nucleophile has added to that carbon. And when we look at these types of structures, these structures are what we refer to as an enolate. We have an alkene and a carbon-oxygen single bond on the same carbon. And enolates, we're going to investigate a little bit later on their chemistry, but if you think about the stability of enolates, we can actually draw a resonance structure of the enolate where we take a pair of electrons from the negative oxygen, donate them to form a carbon-oxygen double bond, so we're creating a carbonyl, and then we can place a pair of pi electrons from the carbon-carbon alkene bond onto the carbon at the end. And what we generate is this particular resonance structure. So these are two resonance structures of the enolate, and we'll discuss the chemistry of those later on in the semester. But they're fairly basic in nature, so they'll react with any proton source that's available, and so we get the protonation of that negative carbon, that carbanion, and we generate this. And so if you think about what this is it is an acyl compound. So ketenes can be used to make carboxylic acid derivatives, basically, right? If my nucleophile is an alcohol, ketenes can make esters. If it's an amide, they can make, if my nucleophile is an amine, it can make amides. If my nucleophile is a thiol, it can make thioesters, and so on and so forth. And so just to take a look at a few examples here, if I take a ketene and I react it with an alcohol, right? The alcohol attacks the carbon. I form my enolate. The enolate then gets protonated, and I generate an ester. So alcohols with ketenes generate esters. Likewise, I can take a ketene and react it with a thiol. And so the sulfur, in this case, is the nucleophile, attacks the sp carbon, and I get thioesters, not thioethers, thioesters. And I said that the carbon can have R groups coming off of it, so just to kind of give you a flavor of just the bond line formula of ketenes, right? So the one of the carbons is sp2 hybridized, and then that central carbon is sp hybridized, so it's linear. We can draw it looking like this. So here I have an ethyl group coming off of that ketene, and if I react it with dimethylamine, then I'm going to generate my dimethylbutanamide. Right? So this is a fairly easy, quick way of of making carboxylic acid derivatives. One key thing to kind of keep in mind is to keep track of the carbons. When you have these linear compounds, sometimes the carbons can get lost in translation. So when you're drawing the products of these reactions, it might be a good idea to take the time and number the carbons, right? So on my ketene on the left here, I can number them 1, 2, 3, 4, right? So I have 4 carbons, and therefore I should have a total of 4 carbons, and of course that fourth carbon should be a carbonyl, and I see 1, 2, 3, 4. That's one way that you can, you know, not ensure that you're not messing up, you're not missing a carbon in the product that you're drawing. Okay, so really basic chemistry of ketenes, not a lot to them, but they are kind of, we classify them as acyl-like compounds because they make other derivatives. We could react it with water and we could make carboxylic acids, right? So keep that in mind when you're studying these types of compounds, ketenes.